Hello everyone, welcome back to CloudOps Craft. Today we are going to do next the CPU monitoring. Let's start. First is we will learn about monitoring memory with the free. So let's dive into terminal to everything practically. First is free hyphen h. Okay. Free shows memory usage in real. Hyphen h makes the output human data, which is MB. You can see this output, right? So here this total is there, no? Total equal to total RAM. Here user is the right memory actually used by process. Free is completely unused and buffer and cache is there, no? This is memory used for catching. Linux will reclaim it when needed. Okay? And swap is there, right? It's a disk based backup when RAMs runs out. And you can see shared. Okay? This shows memory used by temporary FS, shared memory segment. Applications that use shared memory will inter-process some desktop apps or Docker content use this. In servers, these numbers is often small. Okay? Even you can see here, okay, unless apps explicitly use temp fs. And available, you can see, right? Available is the most important column. It estimates how much memory can still be given to applications without swapping. It includes free space and plus reclaimable cache and buffers, since Linux can drop them if needed. So in short, shared is like memory used for shared file system, rarely critical. And while coming to available, this is the real measure of how much memory can still use without eating. Okay, the example, if I want to explain with an example, think of RAM as your office desk. Okay, you can keep active files open and work on them quickly. Okay, but if disk gets full, you temporarily move files into storeroom, swap space. Here disk RAM is right, like fast but limited. Storeroom, which is swap, large but slow. Okay, if you rely too much on swap, your work slows down or dramatically. So next is memory monitoring system uptime. Okay, you can use uptime command to do it. You can see the uptime, right? Like here, this indicates, right? So it's how long system has been running without reboot. And load average. Here you can see load average. Some load, okay, number of tasks waiting for. And like while coming to rule of thumb, load equal to 1.0, okay, then one CPU fully busy. If you have four CPUs, if load is 4.0, then 100% busy. If load is higher than CPU count, tasks are waiting. Okay? Here everything is zero. Okay? So CPU bottle like if load is higher than CPU, here it is low. Okay, like for example, think of load average is like a supermarket checkout counter. So if you have four counters and four people, service is more, right? If 10 people are waiting but only four counters exist, queues are building up. That's a CPU bottleneck. I hope you understood. Monitoring with vmstat. For example, if I type vmstat 2, what this 2 indicates, refreshes every 2 seconds. Okay, it will refresh every 2 seconds. So let me explain this. Here R is there, right? R is for process waiting for CPU. And free. Free is a free memory. And you can see SI and S4. It is a swap in and swap out. And you can see US, SY, ID, W, and this is all CPU usage breakdown. User, system, idle, waiting on input, output, everything. Okay. vmstat is like the CPU health monitor in a hospital. It gives you a live heartbeat of CPU memory and processors, updating every few seconds. Okay. Every 2 seconds it will update. Here R is runnable process, okay, waiting for CPU. If it is 0, then no process is waiting, CPU is idle. If it is greater than 0, number of CPUs and the CPU bottleneck. And B is right, this is blocked process, waiting for IO, like a disk or network. 0 means no IO bottleneck. Okay. Higher numbers mean process are stuck waiting for slow disks. Okay. R is like people waiting at checkout counters. B is like people stuck because the payment machine. Okay. Swap used, this is swap used, and free. Swap D is swap used in KBs. Okay, if it is 0, then great. Okay. No swapping is needed. And free is that right? This is unused memory. It is in KB. Okay, it is in KB. And buff, it's a memory used for buffers, metadata for block device. It helps the kernel manage, read and write. Cache, memory used for file cache, cached files to speed up future access. Okay? Note, buffer plus cache can be reclaimed if needed. No, so don't panic if free is small. While coming to swap activity, here you can swap in. Okay, in it is in kbps. Okay, data moved from disk to ram, and S4 is swap out. Okay, data moved from ram to disk. Okay, both are 0 in our output, means no swapping, system is healthy. Okay. IO, IO is BI for blocking. It is also in KBs. Okay. Data read from disk. Okay. Here it was 21 kbps. Okay, which is small read activity. VO is block out. Okay, which is also in KBs. Data return to disk. Okay, data read from disk. Data return to disk. Okay, small write activity. If BI and BO or I, okay, and B for blocked process, right, is greater than 0, then IO bottleneck. Okay, it indicates IO. Okay, and the system activity in and CS you can. In is interrupts per second, hardware plus. Here it is 16, which is very low and normal. And CS context, context switches per second, which is 25. Okay, it's very low, normal. If it is high number, too many processors are competing for, and this is CPU. So US for CPU percentage. Okay, SY for system CPU, ID for ideal, WF for input output weight. Okay, and ST for steal time. Okay, in our output everything user system and weight and steal time is 0 only. Ideal, okay, ideal as, like, I have a question for you. Have you ever seen a server freeze during peak traffic because CPU load, which is high? Then, if it is high, then how do you fix it? Okay, if let me know on the comment, okay, so I can understand how you handle it. So, now you know how to monitor memory, track CPU load, and even stimulate traffic surges with stress. Okay? Like even you can do stress test. Okay, how you can do stress test is you can install stress. After installing stress, for example, now I'll show you sudo apt install stress convoy. Actually, I am using AWS VM only. For example, if I use stress C hyphen CPU 0.5, if I use more than it, load will be more. VM hyphen bytes. Let me explain. I'll try. It's okay. And the thing is, stress is CPU. I given as 0.5 means it keep 0.5 CPU cores. VM1 is allocate memory stress process. VM bytes 256 means uses 256 MB of RAM. Timeout is 60. It will run test for 60 seconds because I can't give 0, it's 0.5. One, no, it will run that for 60 seconds. In meantime, we can monitor with this vmstat. Open the same terminal here. Now I'll use vmstat. Here, previously R was 0, now 2. This is how you have to run stress test. This is how you have to run the install stress tool, and you can. Okay, these are the skills that keep your Linux servers healthy, and it was success. If you like this breakdown, subscribe to Cloud Ops. Will simplify cloud and dev every week. Thank you.